All right, we are here, and welcome to everyone. We're about to enjoy. We're about to go through a nice ride. We're about to enjoy. We'll go through a few questions. We'll be doing questions from now till you go and write your test, and we'll be just trying to do all the types of questions that you are going to meet in the test to make sure you are ready. Let's see how it goes. I hope you're going to enjoy. I trust we will. What I'm going to do is, I know multiple choice is a very, very thing, and I'm going to come back and make sure that we talk about it and we'll go through some of the things. What I want to do is give you a picture of what your test one is like, right? Then we're going to start going through the things, starting with the hardest, the things that I feel are things that you can easily lose marks on. So I'm going to start with those things. Let us enjoy. I'm going to give you a summary of your test, then we'll come back and we'll start attacking paper after paper, question after question, tutorials and all these things, just from now until you write. So make sure you are settled, make sure you're enjoying yourself, and let's enjoy the ride. Now, first of all, this is going to be our BIUST Chem 101 2025 26 test 1. All right, so and obviously today is 24 September 2025, so we can put that 24/09/2025. We are now, let's go through the questions, let's go through everything, and let's enjoy. In this test, we are having 4 chapters coming. Okay, we have lecture 1. Okay, we'll talk about everything. We have lecture 1, then we have lecture 2, 3, 4, and 5. Let's put it lecture 3, lecture 3, lecture 4, and I'm going to be just doing questions. So, but I just want you to have the picture, because that is what we are going to be referencing as we do the questions, to see how easy it is. I want you to make sure you see how easy it is. Very easy, very easy. We have to make sure we get these marks. So in our lecture, we start, if we say back to front, lecture 4 is just going to be reactions in aqueous solution, which we can say in some reactions in water, H2O. And we only have to know 3 reactions. Okay, we only have to know the 3 reactions that are in aqueous solution. 1 is precipitation. I'm not starting here because I kind of did it a lot. I'll end here. Precipitation, and then 2 is acid base. Then for 3 we have redox. I'm going to start with naming for this one, but I just want you to see the picture of everything, and then we'll enjoy. Lecture 3 is now stoichiometry. Okay, lecture 3 is stoichiometry, and in here, that is where you are asked things like the yield, okay, the different types of yields, percentage yield, actual yield, theoretical yield. Actual yield you are given, but we have theoretical yield, all these. And we are going to find here extent of a reaction. We are going to do questions that involve dilution. We are going to do questions that involve, different things, different questions. And we'll see how we're going to be calculating things to do with stoichiometry. Because in here, we'll also be finding the limiting reactant or the limiting reagent. It's the same thing. Different words meaning the same thing. We'll see how it goes on that. Now, we have also lecture 2. And in our lecture 2, what is lecture 2 about? Mostly, that is where you find naming. In lecture 2, we are looking at compounds. And we will also need to know how to name compounds. We will also need to know how to find certain things, okay? Because when we do compounds, we also learn about the different types of masses. You need to know what is molar mass, what is the atomic mass, what is the formula mass, and you also know about the formulas. What is the formula unit? What is the molecular formula? And all these, we have to talk about it. What is the empirical formula? And you do questions on empirical formula, by the way, also in stoichiometry, where you're going to be finding. We'll go through this past paper, analyze it together, but we have to see these 4 lecture slides. We have to see. Lecture 1 is an introduction. If it's less than lecture 1 is an introduction, and in the introduction, so okay, here in compounds we say you do naming, then you do formulas. Okay, you need to know formulas. Then you are going to do the number of ions. You should find the number of ions, and you should be also able to find the number of atoms when you are given something. We'll see the questions and we'll see how it goes. Here in intro, we are going to need to know quite a few things: the types of errors, what are the mixtures, and whatever. it's a lot. So types of errors, and we will see what is accuracy versus precision. We'll talk about significant figures, but here there is something which is very important, which you are trained, and that is dimensional analysis, which we are going to use throughout this test. If you're good at dimensional analysis, then my friend, you're going to pass. You just need to start doing these questions and make sure you're ready. So let's go through it together and let's enjoy. Give me a sec. All right, so now let's quickly go through the questions and let's see how it goes. Here we are starting. This is going to be the first. I'm going to go to section B here. Section B, and we want to start by talking about naming. Remember that naming is going to be in lecture 2. Lecture 3 is about stoichiometry. That is where we find things like theoretical yield, things like the mass that you're going to get, which is a yield. That is the theoretical yield. And you're going to find things like dilution. What is the molarity after you dilute, or what is these other things? We're going to be finding that. That is lecture 3. In lecture 4, it is just reactions in aqueous solution. We'll see the type of questions that come. Let's start with naming. Now, I'm going to give you the theory around it, and we're going to talk about it. We'll try. But what I want you to analyze, let's analyze. This is section B, and we're starting with number 1. Let's analyze the way a question can come. Here we have, this is our question 1, section B, which is 10 marks. Either they can say, name the following compounds, and then they give you the formulas. Here they are giving us formulas here. Or they are going to say, write the chemical formula, then they will give you the names. They'll say, write the chemical formula, then they'll give you the names. So we want to be able to name if we're given the formula, and put the formula if we're given the name. And I want you to know that all of this will be just revolving around the same thing. And that same thing is the principles of naming. If we're good at the principles of naming, then we shouldn't have a problem. Now, when you are naming, you are going to need to section it. Let me go somewhere down here and let's do naming. When you are doing naming, you're going to need to section. So here is our thing. When we are going through naming, we have to learn how to section, or the different types of naming. Let us put the name. When you are naming, first of all, we will start with naming part 1, binary compounds. Binary compounds, it means naming compounds that have 2 things and 2 things only. We'll go back to our question 1 and we'll analyze after we are done with this one. We'll go back to our question 1 and we'll analyze after we have written this down. Let's talk about how we are going to name binary compounds. Compounds that have 2 things. This is going to have different sections. When you're naming binary, I'll talk first about naming binary compounds where you have a metal and a non-metal. Then I'm going to talk about naming binary compounds when you have 2 non-metals. Then I'm going to talk about naming binary compounds that are acids. Binary compounds that are acids. So what are the rules that you must know for naming binary compounds? Now, here is the idea, and we're going to do some examples where we are going to get a formula and we'll name, or we'll get a name and we'll put the formula. When you are naming binary compounds, here is what you must know. Number 1 is when you have a metal plus a non-metal. Remember, binary compounds will be having 2 things. So when you see something with only 2 things and they ask for a name, it is in section 1. You come back to this. Do you know this one? If you know this, then you must be able to name anything that has 2 atoms only, like 2 types of atoms. Binary compounds have only 2 types of atoms. Now, when it's a metal plus a non-metal, remember there will be only 2 types of atoms. If one of the atoms is a metal, then the other one is a non-metal. Then what you're going to do is, how to name it? You are going to write the name. We have to be fast. We don't want to spend time. We're going to write the name of the metal. We're going to write the name of the metal as it is. So metal, say unmodified, as it is. We are going to write the name of the metal as it is, plus what do? You are going to write non-metal when you write the non-metal, it should end with something ide. Okay, non-metal ide. So for your non-metal, you'll be using, you remove the end and you make it end with ide. Okay, so for non-metal, we make it end with ide. So we will write the metal unmodified. The non-metal should end with ide. That's what we're going to do. We'll see examples. We'll see examples for this one. Should I give you an example? We should be quick. We should not waste time. But what I want you to say, maybe before I go, is put in brackets to say, for transition metals, do not leave out, or let me say, put oxidation state in between the names. Okay, and when you're putting it, use Roman numerals. So put oxidation state of the transition metal. We are going to put the oxidation state of the transition metal in between. Let's do some names. Let's do some types of examples. This is a binary compound, and you're going to see that one is a metal, the other one is a non-metal. Now, what should you do? The metal, you should write the name as it is. Then the non-metal, put non-metal something ide. Put non-metal something ide. Now, what you must know is that you also need to be good at charges. For this one, you are going to need to know what type of ion do I get from each. Let's do examples. Then we're going to go to that test. Let's do examples. Example number one. Part number examples. It will say, let's say they say deduce the formulas. Deduce the formulas for the compounds. Deduce the formulas for the compounds. Then we do this. We say barium oxide. We want to deduce the formula of barium oxide. Now, point number one, we see that the name of the metal has come as it is. It was unmodified. Then we saw that the name of the non-metal ended with ide. This is the non-metal. It ended with ide. So obviously, this is going to be something with only two things. It's binary. It's binary, but now we want to put its formula. Now, when you're putting formulas for binary for these guys, remember to look at the charges. So barium is going to be Ba2+, because barium is from group 2. Oxygen is always 2-. So here we have Ba2+ and Ba2-. So we now can combine. So we find its formula. The 2+, the 2 comes here. You should know when you're combining, you swap. So 2 goes there 2, and you have like a Ba2O2, which you just simplify. The 2's cancel, you have a BaO. So here we have our barium oxide. We know that it had only 2 things. So, name to formula is not hard. Let's do this one now. Ion 3 sulfide. Ion 3 sulfide. What does 3 tell me? The oxidation state of ion. So this is Fe3+. I want the formula now. Okay, I want the formula. Then now I'm going to say, what is the oxidation state of this sulfide ion? If you want to find the oxidation state of this sulfide ion, you check what group is it in, right? So that you can be able to predict its valency. Let me go with you to the periodic table. All right, here is our periodic table, and we are going to go to the sulfide ion here, and we see that it is in group 6. This 16 is group 6, which means that it is going to have an S2-, just like oxygen, because oxygen had a 2-. S2-. It needs 2 to get to 8. That is why we have it as an S2-. Anyway, so what we are going to do is our sulfur is 2-. So here we saw Fe3+, then we have S2-. Now, how do they combine? The 2 comes here, the 3 goes there. So it will be Fe2S3. So here it is Fe2S3. Why did we know that it was going to be something that is binary? It's because the name ends with ide. You have the metal plus ide. That's a binary compound. That has only 2 types of atoms. In here, it's ion and the sulfur atom. Right? These are the only 2 types. And that is why it will end with ide. For your metal, you remember you bring it unchanged. Now we are going to say, okay, I'm fine with this one. Okay, let's do just the second part. Name the following. I don't want us to spend time. Name the following compounds. So we will now say, okay, now we want to name the following compounds. Let's have them. Name the following compounds. One is going to be AlF3. You have been given this and they ask you to name. What are you going to do? You're going to recognize that it's binary. It has only two things. And one is a metal. The other one is a non-metal. We said when we are naming, you bring the metal first. The metal is aluminium. Then the F will now come with something I'd. And this aluminium is not a transition metal, so we don't have to put its oxidation state. It's just going to be aluminium, then fluoride. There we go. Then we now do number 2. What is it going to be? Cu2O. What do we have now? A metal and a non-metal, and they're binary. It's just the two of them. We want the name. So how do I get the name? I know that I'm going to bring copper as it is. So this is going to be copper, but I need to put its oxidation state. How do I put the oxidation state of copper? You take this back and this back if you're going back to ions. So this will be Cu plus, and then we have O2 minus. This is what we have. Okay, we have Cu plus and O2 minus, because these two will go back to O. These are the charges, and these two will then tell you need two of them, but whatever. So this is going to be copper, and copper is a transition metal. What is its oxidation state? Is +1. So this will be copper 1, and then you say oxide. This is going to be copper 1, and you say oxide because this is a non-metal and is at the end. Okay, this is what we're going to do for naming. Now let's go to the second type of naming. I now know I'm in binary. We've done metal plus non-metal. Skip a line and say B now. You are going to say for B, it is 2 non-metal. So it's going to be, how do I now name when it's a non-metal plus another non-metal? How do I now name when I have 2 non-metals? How do I now name? So when you want to name and you have 2 non-metals, then what you must be able to do is, here's what happens. Let's put the rules so that everybody can see the rules for what we do when we have 2 non-metals. What you must know is that you have non-metal plus non-metal. You want to know its name. You see, you have 2 non-metal, only 2 types of atoms. This works when we have only 2 types of atoms. Now, what you must know is that the first type of atom, for here, what should you do? The name is unchanged. Unchanged. Okay, the name of the first type of atom, remember, it will be a non-metal. Its name is going to be unchanged, right? Okay, then what? We now say plus. What will happen to the second one now? We know that the first one, its name will be unchanged. But what will happen to the second one? We'll do exactly like we did. It's going to be a second atom. What will it be? It will give you non-metal, then something I'd. Okay, something I'd. If it's a fluorine, it will be fluoride. If the second is a chlorine, it will be chloride. It will just depend on what the second one is. That's what you're going to do. Now, there is one thing to remember, is just that prefixes must be used, though. Okay, prefixes must be used, and your prefixes are going to be, let's put the prefixes, it must be used. When we have 1, we say mono. 2, this is going to be di. 3, tri. 4, tetra. Tetra. 5, penta. So let's see what we are already seeing. 5 from 5 is now penta, polygons. Again, 6 is hexa. 7 will be hepta. 8 will be octa. 9 will be nona. And 10 will be deca. These are the prefixes we need. We need these prefixes when we are naming something that is binary and it has just 2 non-metals. What we are going to use to know the formula is not the charge. For here, when we were given the name to get the formula, what did we do? We put the barium as an ion, then the oxygen as an ion, and we crossed their charges to get the formula. In here, you don't cross no charges. How do you get a formula from a name here? You are going to analyze the prefixes. You just analyze the prefixes. In the name, they will tell you how many carbons are there, how many hydrogens are there, everything will be told. So in here are the prefixes. Okay? So now let's go and do 2 questions and let's see how we are going to name. Let's go and do a few questions. Here it's going to say, name the following compounds. Name the following compounds. Then what does it give us? Name the following compounds. I, you get PCl5. II, you get B2BR4. III, you're going to get CO2. SF6 and then NO, which will be our number 5. Let's say NO. Let's name these things. We name it in no time. So what is this going to be? This is going to be phosphorus. Remember, the first one comes as it is. Then here we have 5 chlorine, so it will be pentachloride. Remember, it's a chloride because it ends with "ide." But don't forget the prefixes. Do not. For nonmetals, don't forget the prefix. Here it's bromine. Oh, no, this is boron. So here it's going to be boron. Then the bromine is 4, so it is bromine. Here it is bromine tetrabromate. Why tetra? Because there are 4. So tetrabromide, sorry. Tetrabromide. Not bromate, bromide. Because for 2 it ends with IDE. Now we go to the next. Carbon. The first name you put it as it is. So here, by the way, let's put, here is boron, but there are 2. So you should not just say boron. You should say diboron. Diboron. Don't forget the prefix, even if you have 2 on the first one. Then you have to put the prefix. Even on the first part. If there are 2, you say di. If there are 3, you say tri. For that first atom, yes. For him as well. Here it is carbon, but I see that this is a 2-atom thing. I should be able to name this. I have to. This is carbon, but there are 2 oxygens, so it will be di, then oxide. It will be oxide. Then here we have SF6. What is it going to be? Sulfur. Then in here, it is going to be what? 6 is going to be what? Hexa. Then fluoride. Fluoride. Don't forget it's fluoride. Then here now, this is going to be nitrogen. You bring the first name as it is. But here you now say monoxide because it's 1 oxide. Now here you are seeing a lot. You are seeing that when we are naming, don't forget that when we are naming and you have a binary and it's both non-metals, I should not forget my prefixes and I will be fine. Now here, let's say, they now say here the second part. Here they are now saying, deduce the formulas. Here, deduce the formulas of the following compounds. Here, what are we going to say? Deduce the formulas of the following compounds. How do you deduce the formulas? Let's see the compounds they want. It's going to be, and we should be fine, dinitrogen, so here it's dinitrogen monoxide. Then we have 2 carbon tetrachloride. There is no charge to be remembered here. You just say this is dinitrogen, so it will be N2. Then monoxide, it will be O. 1 oxygen. Then carbon will be C. Tetrachloride will be Cl4. You see? Then you're going to keep going and you'll meet any other one which is going to be important. So what are we going to have? Maybe let me just put the last one. Okay. So what we are going to do now is type 3. We'll say, so it'll be phosphorus. So here, that says phosphorus trichloride. What do I get? Phosphorus P, trichloride, chlorine 3. Done. Done. You don't have to know anything about ions. You don't. Good. So for binary, I'm good. There's one more thing. If I get a metal and a non-metal co-binary, I can name it. If I get two non-metals, I can name it. Now, the last thing is going to be, okay, we can use the binary compounds that have a metal and a non-metal. Then we can write these ones that are going to have what? Here, that are going to have, we have phosphorus tetrachloride. What happens now in phosphorus tetrachloride? We're then just going to put the name. Anyway, we go on. Give me one sec, and we're going to go on. Okay, yes, we'll be taking water breaks. So when you need a water break, I will be giving you that. Now, what are we doing now? Let's do the last part of binary. So for binary, it is into 3. Remember, binary is the first section where we are only going to be meeting 2 things, and it is into 3 parts. A, metal plus non-metal. B, non-metal plus non-metal. Then C is binary acids. This is what I wanted to tell you before I took water break. Binary acids now, what are we going to have for our binary acids? Here's the thing. Binary acids are just things that have hydrogen. And you can easily see them because they start with H. They start with an H. Those are going to be acids. For example, you have HI, you have HF, you have H whatever. These are all acids and they are binary acids. How do you name binary acids? First is going to be, okay, or let's say prefix, or the first name. Prefix is going to be hydro. Then, what do you now put as your suffix? Suffix was going to be, remember, for binary acids, you have H and X. These are acids. And what makes them binary is they have only 2 types of atoms. HI, or HF, or HCl, or H whatever. You start with the hydro, then suffix is going to be X-ic acid. Okay, it's going to be the X, which is the here, the other atom which will be here. It is going to be X, then dash 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 ic acid. So you'll put the name of that X, then you end it with ic acid. So it's hydro something ic acid. Here is an example. This is not even hard. This is not hard. We should do them in no problem. So what are we going to have? Let's put it here. Let's do examples. What are you going to do? Here it says name the following. Name the following compounds. Let's name them. If they give me a formula, from here we go to the past paper and we solve all binary in the past paper. We must be able to solve them because we have seen this. So if I have HF aqueous, then how am I going to name this? What is going to be the name? I see, oh, it's an acid. It starts with an H and it's binary because it has only two things. So I say hydro, then I don't space, I continue. It's going to be fluoric acid. So this is hydrofluoric acid. Then here I have two, it is H2S aqueous. This is going to be hydro because I see, oh, okay, it starts with an H and you have H and S, so this is an acid. So it will be sulfuric acid. This is going to be my H2S. Okay, that's what it is. Remember, for the acid, it ends with ic. Then here, now we are doing the second, which is now saying deduce. Here now say deduce the formulas. Okay, deduce the formulas of the following acids. Let's put the formulas. They've given me the name hydrochloric acid. Hydro H. As I say, then chloric acid Cl. Then here we have hydroiodic acid. Then we have hydrobromic acid. Let's put for here hydroiodic acid HI, hydrobromic acid HBr. Here we have the binary acids and we are done. Let's go to our paper and let's do the questions. He has two things. Here, can you see that for part AI, it has two things. Here it has two things. Here it has two things. Sulfide. So this is obviously di. Here we have two things. It's obviously binary. Then we have sodium carbonate. Now let's name. Start with this, writing the name. So I have SeBr4. Now you can go to your periodic table and see, is Se a metal or it's not? Here's the periodic table. Look for Se in your periodic table. Where's the Se going to be? And we want to see, is it a metal or it's not a metal? So here we are going to look for it. Where's the Se? Se. Was it Se? Let me just confirm again. Yes, it's SeBr4. So now what happens? We'll look for it. Se. Here. Sorry for taking. Here's my Se. So now it's a non-metal. And I have Se and Br. So these are two nonmetals, guys. What should I do? Do not leave the prefix. That's the only rule. So my friend, yes, Se, is it selenium? I don't know. Yeah, selenium, you saw it. Then these are 4 bromides, so it is tetrabromide. So he got this correct now when he did this. So you write the first thing as it is, then the second one you write it, but don't forget the number of things matter. Okay? Now let's say CaS. What is it going to be? Calcium as it is, S sulfide. Okay, this one is not even hard to come from this to a name. It's not hard. It's binary, a metal plus a non-metal. We know the metal comes as it is. Then for the non-metal, you say non-metalide. But you say, you know that if you're going to come from the name to go back to the formula, first look at the charges, Ca2 plus, and then you see the charge on sulfur and you see how they'll come. All right, now anyway, let's do this last one. We have copper and then we have iodine. So what are we going to say? It is, remember, this is now a transition metal. When you have a transition metal, remember to put its oxidation state. How do I see? Because this is binary, metal plus non-metal, but there is a transition metal here. Remember, because this is not non-metals, don't say dibromide. Hey, no. Dibromide is when you have 2 non-metals. You don't have a metal when you say dibromide. Here it is what? Or iodide. This is going to, yes, it's a binary, so we know it's going to end as ide. Okay, but it will end as iodide, not diiodide, because there is a metal plus a non-metal. But for this metal, check its oxidation state. Remember, you have CuI2. So when you're going back, you say this 2 here, then this here. So it is Cu2 plus, then I. So what are we going to have here? It's copper 2, then iodide. Done. So here it is, we'll be done. Let's come down here to find I'm giving you some time to put it down. Diphosphorus pentoxide. Pentoxide, it ends with ide. It's binary. Every binary you gotta solve. But here it is diphosphorus. So you know that once I see this, both di and pent, this means that I will be having no, remember, this means that I'll be having no metal. These are 2 non-metals. So diphosphorus means it's phosphorus 2. Pentoxide, it means it's oxygen 5. Because pent is 5. So this is going to be P2O5, not this, what he had written. Then chromium 4 sulfide, you know that it will be Cr4 plus. And then sulfur. Sulfur, I think it is 2 minus. Then you can cross. It will be Cr2S4. So here it will be Cr2S4. Here, this will be CrS2. Are you seeing this? Chromium 4 sulfide. So for my chromium, remember, yes, I've already found it. So, and I put it here. Remember, it was Cr2, then S4. You swap. But then we simplified, so it becomes Cr. The 2 into 2 is 1, into 4 is 2. So it'll be Cr S2. But for your chromium, remember to say Cr4, then S2. Right? Especially in the name. When in the formula, you don't have to. It's just CrS2. You're fine. So here, you got it correct when you put CrS2. Anyway, this is the naming. You've practiced with me some naming. Now let's go to the second part. I hope for binary you're fine. When you see 2 things, you highlight this is binary. And you try to use the rules. Practice makes perfect. These are binary. And here they are ending with ide. So they are going to be binary. They are ending with ide. Now, and we got no acid. So, okay, fine. Sodium carbonate doesn't have 2 things, by the way. It's sodium, then carbon, then oxygen. So that's why. Let's now go to us naming these things. Sodium carbonate, nitrate, monohydrate, bromous acid, this one, iodic acid, potassium chromate. Let's go and name them now. Here we are doing the second part of naming. We're done with the first part of binary. We are now going to the second part. Second part of naming, yes. What is it going to be? Part number 2. Here you have to practice with me and make sure you are fine. We are now going to be naming things that have what we call oxo ions. Don't worry about us. It's kind of like a list which I will need you to kind of remember, and from there we'll be fine. So what is it that I'm going to need to know? So just say The first one was for binary. So in here, I want you to say naming of salts with oxo anions. Plus, here we're naming salts with that, plus naming oxo acids. So here, this is naming oxo acids. Let's see how to name them. Salts with oxo anions, and then these oxo acids. Then, okay, we'll talk about hydrates after this. And then naming this, we'll do the hydrates as the third and final thing. Let's start with the things that have oxo anions. Here's the thing. The things that have oxo anions, I'll give you with these oxo anions what they are. But here you should, when we are naming, it's going to be hypo, then something ita. Then you're going to have ite, then you're going to have 8, then you're going to have per 8. These are how we're going to be naming our oxo anions, and you just have to cram them. If you know the oxo anions by heart, you are halfway there. So my oxo anions, what do? We're going to do from here, we just do question, and the other stoichiometry, and we'll be going like that. So here when we are naming, let's see the ones that I should remember. We know that they can have hypoite, then they can have ite, then 8, then per 8. Now, here's the first thing. We're going to start with the first thing. It is going to be chlorine and bromine and iodine. Here, we talk about it in naming. So what should we say? For these guys, they have ClO4 minus, ClO4 or ClO3 rather, then we can start at ClO, then ClO2, then ClO3, and it's always minus, then ClO4 minus. Here's what we have for chlorine, and it's the same for bromine. It'll be just a BrO minus. It's just a BrO2 minus. It's just a BrO3 minus. Here's just a Br. So, and it's the same for iodine. These things, I've put them because usually you see them talk about chlorine, but I want you to know it's for anything which is in group 7. Okay? Here's what we'll be having. So it'll be IO format. Let's see now how we are going to name these ones. For chlorine is the only one that is going to follow this order, the whole of it as it is. So here it's going to be hypochlorite. Then here it's going to be chlorite. Then it's going to be chlorate. It's going to be per. Here it's going to be perchlorate. This is how we're going to name. And that's the same, they're all minuses. Remember their charges. That's for chromine, bromine, whatever. So bromine, it's bromite, it's hypobromite, bromate, and perbromate. Depending on the ion you are going to get. This is going to be the last name. So here we are telling you this is going to be the surname, or say the suffix of things that have oxo anions. You have to know what name. Know now. You have to know, okay, who comes for chlorine, who comes for sulfur, who comes for carbon, and who comes for nitrogen. You have to be knowing them. There is no running away. So I'm seeing for bromine and for chlorine, the group 7. I'm seeing for group 7. Now, do I end here? No. You do the second one, which is an oxo anion, which you gotta know is sulfur. And who comes for sulfur? You should remember it. We were practicing it yesterday. This is going to be, for sulfur, you have sulfite, then you have sulfate, then you have thiosulfate. Remember we said there is sulfite, then sulfate. For sulfur, you don't have a hyposulfite, you don't have a persulfate, you only have sulfite and sulfate. And then you have what we call thiosulfate. So for sulfur, it is SO3 2 minus, then SO4 2 minus, then here it's S2O3 2 minus. So for sulfur, it's all 2 minus. For chlorine, it's all minus. If there is a hypochlorite, if it's for bromine, it will be hypobromite. Hypobromite. Here it will be hypoiodide. Here. And we are going to be using this. We're going to be using this in naming. You have to remember the last part of the name. The things you get are going to be the ones, they are going to be on this list, which we are doing right now. So here we have sulfur. It is sulfite, sulfate, thiosulfate. Remember them. Sulfate is SO3. Then SO4 is now sulfate. Then S2O3 is thiosulfate. So we say whatever the name of the metal, then we'll now put after the name of the metal thiosulfate. If there is sodium, we say sodium thiosulfate. If it's sodium sulfite, we say sodium sulfite. How? We will be knowing. Hey, because we know the anions. You know them. You gotta have to know them. You have to practice them and write them many times. Because this is the surname you're going to put it. Let's see for carbon. There are not too many. Let's see number 3. Number 3 is now carbon. Do I have night? Do I have carbonate? No. What do I have? Carbonate and bicarbonate. So for carbon, you must know I have now carbonate and bicarbonate. And bicarbonate. So carbonate is what? CO3 2 minus. It's like the sulfur, guys. It's a 2 minus. But bicarbonate has now a hydrogen, so it changes to be CO3 minus now because there is a hydrogen taking one off. So it's HCO3 minus. I hope you're seeing this. I hope you are seeing it. Then we are going to go to the next one. So I have seen for carbon. I have seen for the last ones now. You need to know nitrogen. Then you'll need to know chromium. Let's put, I have 3, then I'll put 4. Let's put for 4, nitrogen. Then when we put for nitrogen, we'll put 5, which is going to be for chromium. All right. For nitrogen, what do we have for nitrogen? We have the nitrite and we have the nitrate. So remember for nitrogen, we have nitrite and nitrate. Nitrite, NO2, nitrate, NO3. And both of them are just minuses. It's like sulfite and sulfate. Sulfite is SO3. Then the other one, the sulfate, is now SO4. Here it will be 2 and 3, but it's still the same. Nitrite will be NO2. Then nitrate is NO3. And they're just minuses. For sulfite, it was 2 minus. Just like the carbonate, which was a CO3 2 minus. Anyway, that is for nitrogen. Then I also have to know for chromium. I have to know. There's no running away. There is no running away. You won't be given this. You have to remember. What? Yes. For real? Yes. For chromium, what do I need to know? You need to know that there is chromate and dichromate. It's not bicarbonate. It's dichromate. For chromate, it's just going to be CrO4. This will now be Cr2O7. And both of them are 2 minuses. Hard work never killed a man. If you know these things, we're going to say to you, bravo, mate. You're doing amazing. A fantastic job. Bravo. Here is going to be it. Now, anyway, we should put these last to the 6 and the 7. They're just 1, and it's going to be 6 and 7. If you know them, you're done. Here it is going to be, it's one thing, just one thing. We'll be having a phosphate, and for phosphate, it is a PO4. Then we are going to have a permanganate. Permanganate. This is going to be an MnO4. So here, this is 3 minus, this is minus. Let's restart now. We're going to need to restart to make this table. We have to restart to make this table at least 3 times together until we can make it. You are going to make it at least 9 times. Doesn't help me to do questions whilst you don't remember it. Let's do it about 3 times or 4 times. Let's see how it's going to be, and we're going to need to if we have this table, it's going to really help us if we can remember them. So let's put we'll start with it. Is there a mnemonic we can remember? No, we'll be remembering. You can look closely. Let's go through it. We have the chlorine. You can look closely before we try to do it on our own again. We have our chlorine, and chlorine was O, then O2, O3, O4, and it was just minus, minus, minus. Sulfur was 2 minus, 2 minus, but it was O3, O4, then S2, O3. Then for carbonate, it was CO3 and HCO3, but it is unlike sulfur, which is 2 minus. It is 2 minus for carbonate and a minus for bi. For nitrogen, it is a minus for 2 and 3. Chromate is the last one. Chromate and dichromate. Chromate and dichromate. You have seen CrO4 in this. Then we'll do the phosphate and the permanganate at the end. Phosphate and permanganate, we'll come back to them. Let's start with the things again together, and let's see how. If I can remember, why can't you? Let's see if I can. First one to know is related to chlorine and bromine and whatever. So if I want for chlorine, I'll say ClO, it's a minus. Then I have ClO2, it's a minus. Then I have ClO3, it's a minus. Then I have ClO4, it's a minus. Then it's the same for bromine. This is going to be a hypochlorite. Then here, this is going to be chlorite. Then this is going to be a chlorate. Then this is going to be a perchlorate. Wow. It's the same for bromine and for iodine. It will be iodide, then iodate, then whatever we'll be having this. That's the same. Right? Fluorite, fluorate. This is going to be for group 7. That's how it goes. And you should be able to see end name. This is going to be the surname. What we are learning is the surnames, the last part. The last part, you are going to know it by remembering this. So when you see them, just remember that the first part is just going to be the name, then the name of the metal. Then you look at this ion. Once you see a ClO, you know it should be hypochlorite. If it is a BrO, it is hypobromite. If there is sodium as your metal, it's sodium hypobromite. That's how it works. So I have for chlorine. Next, I'm going to do, let me do it in my own order. Next, I'll do for nitrogen, because it is another one that is a minus only. So NO2 minus and NO3 minus. I have a nitrite. This is going to be nitrite. Then there's going to be nitrate. So thank you, Mr. Nitrogen, for your service. I'm going to go to sulfur. So 3, I'm going to say sulfur. Okay? Next, I'm going to go to sulfur. What did we have? We have an SO3 minus. SO3, it has 2 minus. Then SO4, 2 minus. Then we had an S2O3. And this is a 2 minus as well. I think so. We'll confirm. This is going to be sulfite. This is going to be sulfate. Then this is going to be thiosulfate. I remember that for nitrogen it was NO2, then NO3. Then for sulfur it is sulfite, then sulfate, then thiosulfate. And for sulfur it is SO3, then SO4 instead of NO2 and NO3. So anyway, okay, cool, not a problem with me. Now what are we going to have now? We are going to go to who? Let me put the 3 is carbon maybe. Let me put carbon. I know that I have carbonate, CO3, 2 minus. Then I have the bicarbonate, HCO3 minus. So I can put in whatever order I want. Carbonate and bicarbonate. Once I put carbon, I'm going to think of chromate. I hope I didn't leave anyone. Now I'm going to put the chromate, which is the 4th one. So chromate is CrO4. Then there is Cr2O7. Okay, so we have a CrO4 and we have a Cr2O7. What were the charges? I think chromate is like is like these sulfurs. It's a 2 minus. Now this is going to be chromate, and this is going to be dichromate. Then we have 5. We are doing well. This is fantastic. Now we are going to have number 5. What is going to happen for our number 5? Who have we left out? I'm trying to think. I think we had 7 in our last one. Who did we leave out? It's not coming back. Who did we leave out? I think we had 7. Didn't we have 7? Who did we leave out? Carbon. I can see him. Who is the 5th one? Nitrogen, carbon, sulfur, chlorine. No, we didn't leave out anyone. So anyway, this is the list. So we now have, of course, the phosphate and the permanganate. PO4 for phosphate and MnO4 for permanganate. So it's MnO4. But the difference is the charges. One is minus, the other one is the only 3 minus on this list, which is the phosphate. And this is a minus, and it is the permanganate. So it will end with permanganate. Thank you for making me know the surnames. I feel ready. I feel ready. Thank you for making me know these surnames. I feel ready. Is this all I need? Yes. Okay, there is one more actually to thank, the 7, which was an acetate. It's like this. It's a CH3COO. And once you see a CH3COO, this is going to be your acetate. Anyway, when you just see something from organic chem, carbons, hydrogens, and oxygens, like this for organic chem, just know it will be the acetate because you won't get the other ones. Well done for doing this. Try it again on your own. Do the sulfide, which is 2 minus. Try it on your own. Try it on your own. It looks hard, it looks easy, but make sure you try it on your own to make sure you are good and you don't make a mistake. So for the sulfides, for some of the carbons and the chromiums, they like 2 minuses. And we have, unless something happens, it'll be 2 minus, except like here. Okay? And it'll be fine. Here are the surnames, and we're going to be able to name. The salts we are fine. We know that we just put the name of the salt, of the metal, then we'll put this thing. Now let's do the last part in here of oxo. Oxo, we are doing part 2. Here we are doing oxo anions and oxo acids. Are you saying we are now doing the oxo acids? We want to see how they name the oxo acids. I want you to know that oxo acids are also called ternary acids. Are you hearing me? If you know these names, you can easily do the oxo. If you know these names, you can easily do the oxo. Make sure you know the oxo acid. Make sure you know these names by heart. Now we can easily do the oxo acid. What will happen with the oxo acid? Let's go for it. Our oxo acid will be, just remember this for your oxo acid when naming. Remember that you have a hypochlorite. Can you see this hypo? So our hypochlorite here, this hypobromide, hypoiodide, hypochlorite. What you must know is that when I'm now doing an acid, remember an acid, you can see it because it starts with an H. It's no longer going to be like KClO. If it's KClO, what is this? This is potassium, but because we have, you know what you're going to do when you get into the test, write down all these things down, then you can easily confirm. For KClO, you just go to your list, you see, oh, ClO, I said is the hypochlorite. So that means you're going to say this is potassium hypochlorite. If it was for bromine, it would be hypobromite. So here is what we have, potassium hypochlorite. Now, what happens if instead of potassium, I have a hydrogen, HClO? This is now an acid because it's starting with hydrogen. What should you do? If it's an acid, if in the name there was hypo, like in here there is hypo in the name. If there was hypo in the name, what you must then make sure you do is, you should just know these rules. Here are for acids. Let's put the part 2. We are still in the same for oxo stuff. We are still in oxo, but here we are doing oxo acids. Okay, we are doing oxo acids or ternary acids. So here for oxo acids, what should I know for oxo acids? We've done oxo salts. salts that have oxoanides. Now for oxoacids, what you must know is that hypo, if you have hypo in your name, when you now have the acid, you say hydro. So hypo changes to hydro. Then ite will change to us. Then ate will change to ik. So if you have an ate, it will change to ik. Ite, it will change to us. Woo! Are you sure? Yes. So this is going to be, instead of hypo, it's hydro. Then what? Then you now say here it was chloride, hypochlorite. It's now chlorus. So this is hydrochlorous acid, because the ite is the us and the ate is the ik. Ite changes to us. Ite changes to us. Excuse me. Remember that. Then you have the ate to ik. Remember that part. Please make sure you remember that. Here we have for our oxo acids. Are we done? Yes, we are done with naming. There's one thing which I just want you to know, which is section 3 of naming. And this one, there's nothing to study here. It is just, what do you do when you see something with a .H2O, okay? Or if they name it, they'll say something that is a hydrate. So let's do this. This one is it's just going to tell you what to do. All right. How do I name something like this? COCl2 dot 6H2O. Dot 6H2O. Well, what you're going to do is you're just going to put the names of everything you are seeing here. And then remember that when you're putting you first name this. So it's like, let's say this to make it easy. These first two are going to be something like you name how you would have named when it was binary, or you name how you have named when it was whatever. You name the first part according to the rules which we have just been studying right now. So for here, I'm going to see that this is binary. So it's going to end with ide. And this first is going to be cobalt. But because it's a transition and I'm writing the name, I should put its oxidation state. The 2 will go to it and the 1 will go to chlorine. So this is cobalt 2, then chloride. This is cobalt 2 chloride. So that's what I'm going to do when I'm naming. I say cobalt 2 chloride. Then I now put the hydrate. This is the .H2O. I'll put it. So for .H2O, you just see how many waters were there. Here there were 6. So you now just say hexahydrate. Okay, so you now just say hexahydrate, because 6 for hexa. 6 for hexa. So it's hexahydrate. Done. If it was 7, hepta. You know the prefixes, I wrote them. So here is going to be it. It would have been a dihydrate or whatever if there were 2. If there were 3, it's going to be a tri. If there were 4, it's going to be tetrahydrate. For 5, penta. For 6, hexa. Like we have done. And this is how you're going to do it. You see? Okay. For those, let's say here you have, what about, let's put this one. What if you have CuSO4 dot 5H2O? We know we are going to say pentahydrate because there are 5 waters. But how do we name this first part? Well, we name this first part according to the names which we know. The way we know. So here we are saying that there is an oxo thing, which is an SO4. And SO4 is a sulfate. So this is going to end with sulfate. It's on sulfur. If you don't remember, for sulfur, it was SO3 2 minus SO4 2. You can go check. Remember, you're going to put this list the moment you get into your test. I'll teach you how to do it one more time as we are doing the paper questions. You just go to the list of sulfur. You're going to see SO4 is a sulfate. And you're going to see it is a 2 minus. So here we were going to say, okay, thank you for your information. This is going to be sulfate. It can't change because that's the name we saw on the table. The name on the table is the name that is going to be there. That's the final name. But here, what are we going to put now? Copper. We just put copper sulfate. But remember that this is a transition metal, so we need its oxidation state. We check. This one, we know that it was a 2 minus, and we can see it's 1:1, so this is a 2 plus. So this was going to be copper 2 sulfate. So when we write, we say copper 2 sulfate, then pentahydrate. There we go. And we'll be done. Okay. Thank you for paying attention to this matter. let us go and answer the questions without stopping. We are good. We can name. Let's do it all together. What are we going to do for this one? You come with your pencil and you're going to put your oxoanions. I'll say my oxoanions in whatever order. I can do chlorine, ClO minus, and I know that the one for chlorine will be for all the other group 7s. So there will CO3, ClO4. These are all minus, minus, minus. And here this is a hypochlorite. This is going to be a chlorite. This is going to be a chlorate. This is going to be a perchlorate. Then we now go to nitrogen. We have NO2 minus and we have NO3 minus. And this is going to be nitrite and this is going to be nitrate. If I can remember, what about you? Surely you can. Okay, thank you for then I go to sulfur. SO3 2 minus, SO4 2 minus, then it's S2O3 2 minus. This is going to be your sulfite. This is going to be your sulfate. This is going to be your thiosulfate. Right? Then next will be carbon. We have a CO3, then we have an HCO3. CO3 2 minus. This is the carbonate. Then HCO3 is now a minus. This is going to be a bicarbonate. The moment I do bicarbonate for carbon, it takes me automatically to chromium. That's where my mind ran to. So now I'm going to put chromium. CrO4 2 minus. Then Cr2O7. Here we now have a Cr2O7. Here is again a 2 minus. If I have made a mistake on any, you check, we'll confirm at the end, and we are going to fix. But this is what I know. This is what we have so far. Right now, what are we going to do here? Let's put the thing. What is the one which we have not done? What haven't we done here? 1, 2, 3, 4, 5. Okay, we need 2 more. So here we know the permanganate. Let's put it. It's going to be MnO4 minus. This is the permanganate. Then we have the phosphate, which is going to be the PO4 3 minus. This will be the phosphate. Here, PO4 3 minus. This is going to be your phosphate. And you are done. Oh, we left the acetate. Acetate CH3COO. This is the acetate if you meet. Okay, this is the acetate. We are done here. Remember that this is the chromate. For chromium, all of them are 2 minus. Chromate and the dichromate. All right, so far so good. I cannot see any mistake here. Now we can go ahead and we can answer. That's what you do. Put this down. This table is now when I put this table, I will now know for my oxo acids. At the end, I should just put somewhere in pencil to say for oxo acids. Remember that you are going to have your hydro. Then after you have your hydro, you are going to have what? You are going to have the 8 and the ite. Ite will change to us. The 8 will change to ik. And you are going to enjoy. This is what you have. Then the rest, you go for it. Okay. Especially things that have more than 3 things. So here I'm going to see a CrO4. I go to chromium and I look for CrO4. I see that it is the chromate. Okay. Then what do we want? K2. So that's potassium. Then chromate. Okay. This is chromate because that's the same name. We saw it. Hello. Come on. Now what do we have in this other one here? It was going to be IO4 was going to be a perchlorate here. But now the hydrogen, it is an acid. Now what do we know is, what should we know? We know that it's supposed to be ik at the end. So what do we have here? It is going to be hydroiodic acid. because it had a chlorate. So for 8, we know that it becomes ic. So this is going to be hydroiodic acid. Okay? Because you just clearly stated that the H should be the ic. Okay? And you can write it as 1 to say hydroiodic. You can write the word hydroiodic in 1. So it's hydroiodic. Then acid. We give you your marks. You get your marks. And you're done. Now you come here. There is a hydrate. Okay. So the hydrate has a dot. And because there is non-hydrate, it's dot 9 waters. H2O. Because it's non-hydrate. Iron 3 nitrate. For iron 3 nitrate, this is binary. We talked about it. How do I put binary? I need to put the formula. So I'll say iron 3. It's iron 3 plus. Nitrate is going to be what? Nitrate, you come to this list, guys. Nitrate is NO3 minus. So here, this is going to be an NO3 minus. Now we swap the things, okay? The 3 comes down here. Then the minus, which is a 1, will come here. So we'll end up having what? Fe, then NO3 will be 3 of them because this 3 came down to there. So this is what you have as your iron 3. Then 9 H2O. 9 waters. Wow. Yes. Who is bromous acid now? We know that the as comes from ite. It was a bromite. So for my bromite, I go here. I know that chloride was O2. So bromite is BrO2. So what do I have here? It's an acid. So it will be HBrO2. Okay, there will be an H here. But we know that it's where it came from. So it will be HBrO2. Can you see the practice? I know it's still not yet perfect. You can practice and practice and practice. You will get much better. Let's do this last one, which does not. We are doing things that don't end with "ide." Things that end with "ide" are diatomic. These ones will do it. So what about sodium carbonate? We look for carbonate in here. Carbonate is a CO3 2 minus. So we have a CO3 2 minus. And we have a sodium, Na plus. We switch the charges. So 2 comes down, then 1 goes there. So it's going to be Na2, then CO3. Here it is, and you get your marks. Remember these 8s, these are, we don't, on sulfide doubts, these ones, we don't use the stuff we have been doing right now because these are ending with ide we use. But here for bromous acid and for non-hydrate, we need to be using these theories. Okay, I hope you are good now with naming. Let's take a 5-minute water break and we are going to continue. I'm going to take a 5-minute water break. In the meantime, also, if you haven't subscribed, make sure you go and you subscribe to my channel right away. Make sure you subscribe to my channel. And also, by the way, I'm doing this, but you must know that for month end, please, everybody, come and enroll. Okay, subscribe to my YouTube channel, but please come and enroll for me to tutor you daily from every month. Okay. Come and enroll for tuition. My number is 71383870. Text me on WhatsApp and come enroll for maths, enroll for chem, enroll for physics, enroll for all these things, and we can go ahead and learn together. It's going to be fantastic. So make sure you have enrolled and we can have fun. This is very important. So subscribe to my YouTube, okay? And also make sure that you text me so that you enroll this month and we work together, okay? When we come back, we're going to do the second part and we'll see how it goes.